before studying about the single step or elementary reaction, I'll tell you a little thing about law of mass action, which was given by Goldberg and Bargill. And they said, according to them, they said that rate law can be written as rate constant multiplied by the concentration of the reactants raised to the power their stoichiometric coefficients. But actually the law of mass action, it is not applicable everywhere. This law is not applicable everywhere. That is why we don't study it. Suppose if I simply give you twice of A plus B gives C. And they simply said that the rate law, you can just simply write the rate law by looking at they simply said that you can write the rate law by looking at the chemical reaction. Suppose A to the power 2 and B to the power 1, but this is incorrect. In some of the chemical reactions, this method was applicable, but for some of the chemical reactions, this method actually failed. So we don't study this method, that is law of mass action. Now suppose I'll give you one example. Suppose we know that we have studied this reaction, H2 plus I2, it reacts to form twice of HI, right? So now rate of reaction is equals to K H2 to the power 1 and I2 to the power 1. Now in this case law of mass action is valid, right? Because here the concentration of reactants is actually raised to the power the stoichiometric coefficients. But if we talk about this equation, H2 plus Cl2 gives twice HCl. If we talk about this, now rate of reaction in this case is K. Experimentally it was determined H2 raised to power 0 and Cl2 raised to the power 0, means rate was actually independent. Rate was actually independent of the concentration of the reactants present. So that is why I am saying it again and again that law of mass reaction is not valid everywhere. Now the next topic which we have to study is, I'll give you an idea about the molecularity of a reaction. What is molecularity? See, molecularity is number of molecules, number of reacting species taking part in an elementary reaction, right, which must collide simultaneously to bring about a chemical change is the molecularity. Number of chemical species colliding together, and they must take part in a chemical change to bring about chemical reaction to bring about a chemical change. So suppose a reaction's molecularity can be two molecules can collide. At a particular time, it can also be three molecules. But remember one thing, molecularity of a reaction never exceeds 3. Molecularity is always less than 3 or less than 3. It never exceeds more than 3. If in any equation, any reaction you see, you observe that the molecularity of a reaction is coming out to be greater than 3, it means that reaction is actually, it's not an elementary reaction, it's a complex reaction. And for complex reaction molecularity is not defined, right? So I think this much is clear to you. Suppose I'll give you one example for complex reaction, like you have KClO3, it's given in your NCERT, plus 6 ferrous sulfate plus 3H2SO4. It reacts to give KCl plus thrice ferrous sulfate plus water. So you have to tell like what is the molecularity of this reaction. If you simply observe, you will think that the molecularity is 10, but it's not possible. Molecularity cannot, see, you imagine yourself, like 10 molecules are colliding simultaneously at the same point to give this product. Is it possible? No, it's not possible. Like at 1 second, 10 molecules, they are colliding simultaneously at one place. It's not possible. That is why we say molecularity cannot exist three. This is an example of complex reaction, and we'll discuss the molecularity of complex reaction when I'll be teaching you about complex reactions in detail. So next we have zero order reaction. Let's study about the zero order reaction. Now what is zero order reaction? Zero order reaction means when the rate of the reaction is independent of the concentration of reactants. Suppose we have R is to P, but rate of reaction is independent of the concentration of reactants, and we'll write it as minus dr by dt is equals to rate law K R raised to the power 0, right? R raised, anything raised to the power 0 is 1. So minus dr upon dt is equals to K, right? So this dr is equals to minus K dt. Now if we simply integrate this from R naught to RT, we know that, and when R is equals to 0, at T equals to 0, R is R naught, means initial concentration of reactant. At T equals to T, this concentration of reactant becomes RT. So we'll get on integrating, we'll get this R, and from R naught to RT is equals to minus KT minus KT. So now this is RT minus R naught is equals to minus KT. So if we talk about what is the equation, zero order reaction of zero order reaction is R naught, that is initial concentration of reactant is equals to final concentration plus concentration is time T plus KT, because we know that initial concentration is greater, so R naught is equals to RT plus KT. Now if we want to draw the graph of RT versus T, then I can also write it as RT is equals to R naught minus KT. Simply compare this equation with y equals to C plus mx. Now the slope is negative, right? So let's draw the graph of RT versus T. Concentration of reactant versus T. Time. We know that at T is equals to 0, we have R naught, that is maximum concentration, but as time increases, the concentration is going to decrease. That is why we have negative slope, which is minus K, right? So if you try to find out the value of K from this equation, it comes out to be R naught minus RT by time. This is how you have to do it. I hope this much is clear to you, how to find the zero order reaction, its graph, its equation. For example, we have platinum metal as a catalyst. At high pressure, the metal at surface gets saturated with gas molecules. So what happens? In this case, the reaction is actually a zero order reaction, because even on increasing the concentration, there is no effect, right? So these are the examples of zero order reaction. Now, if I tell you about first order reaction, what is a first order reaction? See what happens in case of first order reaction. Let us discuss about first order reaction also. R is getting converted into P. So rate is, how will you write rate? Is equals to minus dr by dt is equals to K rate constant R to the power 1. So I can simply write it as dr by R is equals to K dt. Now if we simply integrate this equation from 0 to 2t, again R naught to RT, you will get, what is the integration of 1 upon R dr? Its value is ln R, right? And from R naught to RT, it is minus, so it will be minus KT, right? T is from T 0. So now on putting the value, you will get ln of RT upon R naught is equals to minus KT. Yes, minus KT, or we can also write it as RT is equals to R naught e to the power minus KT. If you want to draw the graph of RT versus T like this, RT versus T, since it's exponentially decreasing, so it will be like this, right? Another way of writing this equation is, what is the another way of writing this equation? Is ln will be converted, it will get converted into log, so it will be or else you can also write this equation as, see, ln, this is ln RT is equals to ln R naught minus KT. If you want to write, if you want to draw a graph, a straight line graph, so how can you draw a straight line graph? Very simple. Ln RT versus ln RT versus what? T. We know that maximum concentration is ln R naught, and this low, this is minus Q, right? But I can also do it like, if I want to convert this equation ln base E into log base 10, so I'll multiply this by this log base 10. So I can also write it as log 2.303 log base 10 RT upon R naught is equals to minus KT. Now suppose if I want to remove this minus sign, we can write it as log base 10 R naught by RT is equals to K upon 2.303 T. So now if you draw a graph of log base 10 R naught by RT versus time, you will get a positive graph with a positive slope, whose value is, the value of slope is K upon 2.303. So it depends what type of slope graph you get in exam. Accordingly, you can find the value. Suppose the hydrogenation of ethene, C2H4 plus hydrogenation of ethane, it is an example of first order reaction, right? It depends on the concentration of ethene. I hope this much is clear to you, how to do these type of questions, first order reaction. And what else you can do is, suppose we have this equation with us. See, it's just that you must know how to modify the equation. This is equation ln RT minus, so this is ln RT is equals to ln R naught minus KT. Suppose this is time t1, this is at RT1, right? Now now suppose if this you don't know the initial concentration value, you don't know R naught value. Suppose you also have this R ln R T2 is equals to ln R naught is it minus K2. Now you have been given the value of T1, T2 and R, concentration of R at T1 and T2, and they ask you in exam, find the value of rate constant. How can you find? Just simply, what you have to do, just simply, this is equation first, second, just simply you can subtract one equation from the another, right? Suppose if I tell you subtract 1 from 2, what you can do? You can do ln R T1 minus ln R T2 is equals to minus K T1 minus plus K T2. This can become ln R T1 by R T2. You can simply convert this ln value into log also. I've told you how. Just multiplied by 2.302, and this is K T2 minus T1 simply by using this equation. No need to learn the equation, you just know how to just learn these methods, how to do this, right? Otherwise it becomes really confusing if you keep on learning all the equations.